Hello everyone, welcome back to my channel. So in this video we are going to learn about stable and unstable systems. Okay, if you are first time to my channel, please consider subscribing. So a system is said to be stable if it satisfies Bibo stability criterion. Bibo stability criterion, that is, Bibo stands for bounded input, bounded output. That is, if the input is bounded, then the output should also be bounded. If the input is bounded, output is also bounded, then it is called as a stable system. If the input is bounded, and output is not bounded, that is unbounded output you will getting, then that type of system is said to be unstable system. Okay, so such type of system is said to be unstable system. Okay, so this is the definition of stability. Stability is Bibo criterion. Okay, so if you are given with problems, then how we are going to solve whether the given system is stable or not. So for that, two important points which you have to remember is, in continuous time systems, the only stable input available is u of t. Only stable input available is u of t. So we know that del of t is infinity because it is unbounded. Okay, so I'll tell I have already told you about this in impulse function concept. Okay, so del of t is equal to infinity, and r of t, as t tends to infinity, r of t tends to infinity. R of t also tends to infinity, so it is also unbounded. Okay, so every other standard signal is going to be unbounded only. So only stable input available is u of t. Remember this point. That means in order to find the stability of a continuous time signals, you have to apply the input as u of t, that is x of t is equal to u of t you have to apply. Okay, and by applying x of t is equal to u of t, you have to find the output y of t. So if this y of t is also bounded, because input is bounded, and so if the output is also bounded, then we can say that the given system is stable system. If the input applied is bounded, that is u of t is applied, but the output y of t is unbounded, then we can say that it is an unstable system. So in order to find the stability or instability, you have to apply x of t is equal to u of t for continuous time cases. Just remember this point. Second is, in discrete domain, the stable inputs are del of n and u of n. Okay, so del of n is stable in discrete domain because del of n is equal to 1 for n is equal to 0, is equal to 0 for n not equal to 0. Okay, so del of n is stable in the case of discrete domain, but del of t is not stable in continuous domain. So in discrete domain, you can use either del of n or u of n as the input because both are stable. So bounded input you are applying, and if you get bounded output, then we can say that it is a stable system. Okay, right. So now we'll see some of the problems, then you'll understand the concept very clearly. Right, first question. Here we go. So y of t is equal to x of t minus 3. So as I've told you, this is a continuous time signal, and what is the input which you have to apply? U of t. So y of t is equal to u of t minus 3. Okay, so in the place of x of t you have to substitute with u of t. So y of t now becomes u of t minus 3. What is u of t minus 3? So it starts from 3 and ends at infinity. Even at infinity also its value is going to be 1. So its value u of t minus 3 value is going to be 1. That is, it is going to be bounded only. So for bounded input you are applying the input as x of t is equal to u of t. That is what we have substituted, and still y of t is also obtaining as bounded because y of t is equal to u of t minus 3. Where it is u of t minus 3? This is u of t minus 3. Even at infinity also its value is equal to 1. Okay, so output is also bounded. So bounded input results in bounded output. So the system is stable. So the system is stable. Understood? Right. Next, second question. So y of n is equal to e power x of n. E power x of n. Okay, so you can apply anything. Okay, del of n I will apply. So assuming x of n is equal to del of n, then what is y of n? Y of n is equal to e power del of n. Del of n is equal to 1. So e power 1, which is equal to e. So y of n value is equal to e, which is again bounded. Bounded means giving a finite value. When you got the output here also you are getting it as 1. So if you get it as a finite value, then we can say that it is bounded. If you are getting infinity, then we can say that if y of n is becoming infinity, then we can say that it is unbounded. Okay, so in this case it is bounded, so it is again stable system. Okay, right. Next we'll see y of t is equal to d by dt of x of t. D by dt of x of t. So in continuous domain only stable input applied available is u of t. So therefore for x of t is equal to u of t, then what will be y of t? Y of t is equal to d by dt of u of t. So in the basics of signals I have explained you what is the differentiation of u of t. Differentiation of u of t is your del of t. So del of t is a unbounded input. So del of t is equal to infinity. So when del of t is equal to infinity, then what will be output? Output is going to be unbounded. So when output is unbounded, so output is going to be unbounded, then the system is said to be unstable. That's all. System is said to be unstable. Understood? Very, very important question, this one. Similarly, when you have integration, y of t is equal to integral of minus infinity to t x of t dt. So this is again a continuous time signal. X of t is equal to u of t you have to apply. So y of t is equal to integral of minus infinity to t u of t dt. What is integration of u of t? From the basics I have explained you that it is ramp signal r of t. R of t is again an unbounded signal. As t tends to infinity, r of t also tends to infinity. Okay, it is unbounded output. So y of t is equal to r of t, which is an unbounded output. So in this case also the system is unstable. So in the first two cases we have got a stable output, that is 1 here and E here. E is 2.738 or something you will get. So that is bounded. In the remaining two cases we have got the output as one is del of t and the other is r of t. Both are unbounded outputs. So for bounded input you are applying here as u of t, you are getting unbounded outputs. So therefore systems 3 and 4, in the examples 3 and 4 are said to be unstable signal or unstable systems. Okay, so this is how, or we will take another example, last example. Y of n is equal to n into x of n. Y of n is equal to n into x of n. So we have to say that this is bounded or not. So it is unbounded only. Unbounded system only. What is this n into x of n? If you take x of n is equal to u of n, x of n is equal to u of n, then what is y of n? Y of n is equal to n into u of n. What is n into u of n? It is again a ramp signal only. Ramp signal only. Ramp signal in discrete domain, that's all. t into u of t. Standard form for ramp signal is t into u of t. So here n into u of n, ramp signal in discrete domain. Still ramp signal in discrete domain is also unbounded. Unbounded. Therefore the given system, this system is unstable system. Or you can also solve at n is equal to infinity. At n is equal to infinity, what is y of n? Y of n is equal to infinity multiplied by x of n. Infinity multiplied by anything is also equal to infinity. Infinity multiplied by anything which is a finite quantity, because we are applying here a bounded input, so it is bounded, and infinity multiplied by anything is also equal to infinity. So y of n is now becoming infinity, which is unbounded again. When it is unbounded, then it is an unstable system. Okay, so this is the procedure to find whether the given system is stable or not. Okay.